So here is the second rule we're going to look at in this section. Right, is this f and g are two continuous functions where f is greater than g. F is greater than g means really that the f function is going to be higher right here than the g function over the interval, and we're going from the intervals from a to b. Then the area of the region between the two curves from x equal to a to x is equal to b is equal to this formula here. So all we're doing is basically subtracting the two functions and find a definite integral from a to b. And that will always give us the area. And it doesn't matter if they're above or below the x-axis. All right, so Damien, I think you said number 2 also, right? We're going to skip 2 and come back to it because my MATLAB kind of jumbled their questions. And I want to do them in a particular order, so I'm going to do number 3 first. All right, so here's number 3. And the good news is they gave us a graph. A lot of these questions, they don't give us the graphs. Right? So find the area of the shaded region. So which function is on top, basically, here? Is it f or g?
G.
G, sure.
Talking about the blue line, right?
The line is g, right? So the g function is on top. Dashka, can you see that? You agree with that now? So here, this is the one that's on the top, right? The shaded region is below that, right? And that's our g function. So let's kind of go back up to this rule here. And let's kind of, clarify this. This F1 is on top and this one is on the bottom. So the F and G is really generic. So when we do our formula for this problem, we're going to set up the integral. Where are we taking the integral from? Between A and B, which is our x values. So the shaded region is between which two x values? Are we looking at the same thing? Everyone agree that this is the shaded region, right? Do we agree? Come on, let's see some answers in the chat box. Very good. All right, so this is the leftmost part on this shaded region. What's the x value there? -2. There you go. So that's going to be your lower limit, right? The left limit. Over here on the right, what is the x value? 3. There you go. So that is the upper limit, right? And that's all they're saying up here. And it's always been the same rule we've been doing, you know, even in 4.3. We're just making it a little more applicable now to some stuff. Now, which function did we say was on the top? G. So in this problem, we're going to have g of x minus f of x, right? Because it's always a top function minus a bottom function, regardless of what they call them. In the graph above here, they were calling the top one f and the bottom one g. This is why it's f minus g. So it's always a top function minus the bottom function. Keep that in mind. Now, if you can do that or understand that, then the rest is relatively, you know, the same thing we have been doing. Or g of x is negative 22x plus 120 minus x to the fourth minus 8x to the third plus 21x squared. And of course, we're taking the integral with respect to x. So what we have to do now is we have to simplify this before, you know, which is just a little algebra, right? We're going to remove the parentheses, negative 22x plus 120 minus x to the fourth. Since it's negative, it gets distributed over everything. Plus 8x to the third minus 21x squared. And we're going to combine the like terms, which is nothing. Whoa. Really? I'm just going to put in descending order. Negative x to the fourth plus 8x to the third minus 21x squared minus 22x plus 120. And we're going to go back and take the integral from -2 to 3. Is everyone okay so far? All we did was subtract two functions and set up the integrals. Damien, does that make sense now? Well, this was your question. All right, so now we're going back to the old rules. We're going to take the antiderivative, you know, of the whole thing. So this, you know, let's start with the, you know, this, then we go work away. So this becomes negative x to the fifth over 5, right? Because we're going back to this rule up here where, you know, you add 1 to the exponent and you divide by the new exponent because n is not equal to -1. Plus 8x to the fourth over 4 minus 21x to the third over 3 minus 22x squared over 2 plus 120x. Is everyone okay with that antiderivative? Is there anything I need to go over? All I did was add 1 to the exponent and divide by the new exponent, right? It's just rule number 2. Here on the end, since this is a constant, all we did was add the x to the end. Now we could probably simplify some of this. This becomes negative x to the fifth over 5. This becomes 2x to the fourth because the 4 goes into 8 2 times. Minus 7x to the third because the 3 goes into that 7 times. Minus 11x squared plus 120x. Now the only thing we need to do now is -2 and 3. We're going to plug in those numbers. And we always plug in the top number first. Don't forget that. So we're going to plug in the 3, then we're going to plug in the -2. So be careful here. So it's negative 3 to the 5th over 5 plus 2 times 3 to the 4th minus 7 times 3 to the 3rd minus 11 times 3 squared plus 120 times 3. That's just plugging in the 3, right? Now we're going to minus plugging in the negative 2. So that becomes negative 2 to the 5th over 5 plus 2 times negative 2 to the 4th minus 7 times negative 2 to the 3rd minus 11 times negative 2 squared plus 120 times negative 2. Any questions on that? No, I'm not even going to worry about the final answer for this. You know, it's just plugging numbers into a calculator. And the answer is always going to be positive. If you get a negative answer, you did something wrong. And the reason why is that because we're always taking the top number, which is larger, and subtracting the bottom number, right? So this ensures that our area is always positive. Because it's a high one minus a low one, we will always get a positive answer. So the difficulty in this problem is right here. Just setting it up, right? If you can set it up, then you should be able to do the questions. Because everything else is the same thing you have done before. So let's try and just set up a few more. Come back to that.
Professor, I have a question.
Sure.
Is it always g of x minus f of x?
It's always the top one minus the bottom one. So it depends on what you call them, right?
Okay.
Does that make sense, Louis? All right, let's look at this one. This is question number 4. And the good news is that they actually gave us the graph, right? So I'm going to cut the graph and paste it in for you too. Louis, yeah, so can you see this? There's actually not even telling you, they're not even calling them F and G, right?
Nope.
They're just calling them Y because they're just two equations regardless. So one is Y, you know, let's call them for our sake Y1 and Y2. So this is Y1 and Y2.
Okay.
Which one is the top? Y1 or Y2?
Which one is what? What was that?
Which graph is on the top? Is it Y1 or Y2?
Whatever the top.
Look, the equations. Let's call this A and this one B. Which one is on the top in terms of the shaded region? Which one is above the shaded region?
A.
You sure? The shaded region.
Wait, no, I'm sorry. B. As far, yeah, it's on the left.
Yeah, we're looking at the shaded region. Don't look at the graph itself, right? Because I agree with you. On the right side, A is above. But just for the shaded region, right?
Yeah, I understand. Okay,
Interested in here, it's the b that's on the top. You agree?
I agree.
Right? All right, so we know we agree that b is on the top. Now let's go over to our equation. Or is it y1 or y2? And how do we know?
What was that question?
Or b, right? The one on the top. Is it equation y1 or equation y2?
Let's see. I'm not sure.
All right, that's fine. Can someone help him or contribute? Any ideas?
Hmm.
Y1, Don, why are you saying Y1? I'm not saying I disagree. I just want to know what's your rationale. Because this is an important question to help everyone. Not just the answer.
It's a straight line. It's like a linear equation.
It's a line. Very good, Anna. Because Y1 is a line. Can you see this?
Mm.
Y1 is just equal to 4x. Right, so we know that's a line. So this is going back to the old school college algebra and intermediate algebra stuff.
Okay.
What else was I going to say? Lewis, yeah. Do you have a graphing calculator?
I don't have a graphing calculator now.
All right, but you know, you can go online and grab some of these questions too, right?
Yeah, that's what I use.
So if you go online and you graph this one,
I would see a straight line.
right? Yeah, you're gonna see that, you know, it looks like this, right? And if you go online, you know, go Google graphing tool, it's gonna look like this, right?
Yes.
So now you can see that this is Y1 and this is Y2, right? So we now establish that B is equal to Y1 and A is equal to Y2. So let's set this up. So we should be able to set this up now.
So we gotta understand.
Is equal to the integral from where?
No, I was just saying to myself that you gotta understand what the graph is telling us in order to choose the correct. Like,
Okay. So let's go back to finding the area. The area is from the left x value on the left endpoint. So what's the x value there?
0.5.
0.5? Is that negative 0.5? It looks like it, right? Or my guess is actually equal to 0. I don't know.
4, 3, 2, 1.
It's 0. They're just telling us.
Oh yeah, 0. That's
The corner plot there is negative 0.5. So our low value on the x is equal to 0. What's the right side of this curve? What's the x value there? So you just tell me that this is 0, right? And this value over here is 4. So what is the x value right here?
2.
2, right? So we're only interested in the x value because we're taking the shaded region, you know, from here to here, the x values. All right, let's go back and finish setting up. Remember, our rule says we're going to take the top equation and minus the bottom equation, right?
Uh-huh.
So which one is the top one right now? Let's go back to what we said earlier. Which one is on top?
Y1.
Y1. So it becomes Y1 minus Y2. There you go. That's it. All we need to do is plug it in now.
Right. That's how you.
So it's not even really about F or G. Is really, you know, they can call them anything they want.
Mm-hmm.
It's the top equation minus the bottom equation, right? So the Y1 then would be 4x minus Y2, which is x to the third, dx. Does that make sense?
Yes.
So when we find the integral of this, it goes going to be from 0 to 2, 4x minus x to the third dx. And then everything is just like we did in 4.3 now, right? Here is going to be the antiderivative of this, which is 4x squared over 2 minus x to the fourth over 4. And we're going to evaluate that from 0 to 2. And that will give us our, our answer. I think we should look at maybe setting up a few more problems, because that's a difficult part. We're going to go to Damon's question number 2. So this is question number 2. Move this down some more. All right, so which one is on top and which one is on bottom? Do we know? FRG, which one is on the top? Does anyone know?
What do we need to see the graph?
All right. We need to see a graph. Good point. And the good news is they gave us a graph. But I want that response for you that we do actually need to see the graph. Because, the first 4 questions are the only ones that give you the graph. From question 7 to 11, they do not give you the graph. So what are you going to have to do?
Use a graph
You
calculator.
have to go graph them yourself.
Yeah.
Right? You're going to learn how to graph if you didn't learn. So in college algebra, you're going to use a graphing tool, right? So which one is on top now? Now that we have a graph. Dashka, do not understand your answer. What is that, a O or a 0? G's on top. Michael, why do you say F? All right, so G is a flat line. G is the blue line. So which one is on top, the F or the G? Alfred, why do you say F, Alfred?
F. I think he's saying F maybe because on the right side of the graph. No, I don't know.
All right, Luis, I like your thought process. Say that again.
I was saying I think he's saying f because on the right side of the graph, it's see how it's going up.
Mm-hmm. But on the left side,
Left side, G's already on top of the shaded area.
exactly. So this is a two-part problem. One part, let's call this part A on the left. G is on top. Do we all agree with that? Right? And for part B over here on the right, the F is on top. Right? So you were both right when you said F and G. I mean, you're all right. But, it's from certain portions. So we're going to have to split this problem up into two parts. So this is the rule that is, going back to this rule above here at the very beginning. Where we're taking the integral over a long distance, we can split it into multiple parts, right? So here we're going to do, part A, and then we're going to do part B. And we're going to set them up as two different areas. So the total area will be the area of A plus the area of B. Do we agree with that? Right? We're just adding the two areas together. I think we can all agree on this, right? Now let's find the area of A. The area of A, we're going to take the integral. What's the x value on the left? So we're looking for the x value here. What is the x value there?
-3.
-3. And the x value on the right?
0.
Would be 0, right? Only for A, Alfred, not all the way, right? Would be 0. Now, for that section A, which function did we say was on top?
G.
So it's going to be G minus F. There you go. So that's the area of A. We're going to plug in the G and the F in a second.
Okay, find the area of A. G minus
All right. Now let's find the area of B. What's the x value to the left side of B?
0.
0. And the number to the right side?
1.
2.
1. Very good. And which one is on the top? F or G?
F.
So this becomes F minus G. Does it make sense to everyone now? Damn, see, this was actually for number 2 problem. This was a little challenging, this was like a leap of faith on my MATLAB, the way they organize their problems. This should have been like number 6. All right, so let's plug them in now. So this becomes, we're still doing part A, and G is 0 minus F, which is 6x squared minus x squared minus x to the third. That's the G part. I mean the A part. And let's just continue simplifying this. So that's -3 to 0. This becomes -6. And I make a, there's no squared on that, 6x. There you go. So this becomes -6, positive -6x plus x squared plus x to the third. Now let's do part B. This goes from 0 to 1 of f. Under f is 6x minus x squared minus x to the third minus 0, since this, right? Our G is just 0, and that's our f. It's f minus g. Is that my phone? Must be someone.
Oh, sorry, that's me.
6x minus x squared minus x to the third. Whew. See, that's the difficult part. Do we think we can handle it from here? I mean, I'm going to take it to the next step. At least, right? But do we think we can handle it from here? Because from here, this is 4.3, right? What are we going to do now? We're going to take the integral, the indefinite integral. So this becomes negative 6x squared over 2 plus x to the third over 3 plus x to the fourth over 4. And we have to plug in the numbers, negative 3 and 0. And on the right side, this becomes 6x squared over 2 minus x to the third over 3 minus x to the fourth over 4. And for this side, we're plugging in 0 and 1. Do I have any questions on this so far? So once again, it was, trying to, determine which graph is on the top, which graph is on the bottom. That is very important. And to do that, you will need the graphs, right? And if you can determine which one is on the top and which one is on the bottom, then you know what your subtraction is going to be. Then you also have to determine the upper and the lower x value for that region. Are we clear on this? All right. I'm going to come back to this last concept in this section.
Very quick question.
Sure.
That's not how the final answer is going to be, is it? Or are you just leaving it because you just?
No, you got to finish this. But
Okay,
this is just.
Gotcha. This is just.
Yeah, I don't. We don't have the time to just plug this into the calculator.
No, it makes
It's
sense.
gonna
I understand.
6 times 0 squared over 2 plus 0 cubed over 3 plus 0 to the fourth over 4, right? And you're going to minus negative 6 times negative 3 squared over 2 plus, negative 3 to the third over 3 plus negative 3 to the third over 4, right? And that's just for the red part.
Yeah, and I get you. Then the right part you're doing it.
And then you have to do the blue part, plug in the 1 and the 0, right? And then you have to combine it all together.
All right.
So that at this stage, it's just plugging stuff in your calculator and evaluating it. Truly, all goes away because this is just a bunch of zeros. All right, let's try one more. That was number 4. All right, let's go number 5. Dashka, I am not sure. I have no control over the recordings when they're posted. I record it and it's Blackboard that actually posts them. So it normally takes Blackboard, a few hours to post, but it could be longer. So I'm not the one posting the recording. It's an automatic post from Blackboard. And which one did we say we're doing? Number 6. So number They're posted right after Michael. Thank you. 6, 7, 8. All right, so 6 and 8 are 3 questions without any graphs. And I didn't make the questions too difficult for you, right? You should be able to do most of these on your own. I tried to make it easy. Or with some little easy graphing tool, you should be able to do it. So here's number 6. No graphs given. So you were right. I think it was Lewis earlier when it says, you know, we do need a graphs to see which one is on the top or which one is on the bottom, or, you know, we need to have a mental picture. And sometimes it even takes a little more than that, right? As we'll see. So right now we don't know what this looks like, but let's start on the first equation. Let's call this y1 again, and the second one y2. Let's start with y1 and try and get a graph for it. Any idea what this graph looks like?
It's a linear equation.
It's a linear equation, so we know we're going to get a lines, right? And these are, you know, not too bad in graphing. They're probably the easiest thing to graph. You could probably just put some points. Is that Jenny? Was that you? I don't.
Yes.
How do you know it was linear?
Because it's in the y equals mx plus b forms.
Very good. And the main thing too is that the degrees are equal to 1. So if the degrees are 1, we know it's linear. Very good. See, Myrta is saying that. Same thing. So because the exponents are 1, you know, sometimes we don't think about these little things, but there are reasons why, you know, this is all we know. And if we plug in points, let's say we plug in 0 and maybe 2. Or maybe 1, since it seems like it gets a little large. Let's plug in 1. So if we plug in 0 into this, we're going to get 3. Because it's 2 times 0, which is 0, plus 3, which is 3. And if we plug in 1, we're going to get 5. Does everyone agree with that, at least? I hope I haven't lost anyone yet. Right? This is just, and you know, I'm not going to spend a lot of time teaching you how to graph linear equation. 1, 2, 3. Let's put some numbers here. 1, 2, 3, 4, 5, 6. So the first point would be 0, 3. And the second point would be 1 and 5. So here we go. So our line is going to look something like this, right? This is our line. The right part is a little crooked, but that's our line. All right, let's do the y2 now. Let's do y2, a little darker color. It's going to be equal to x squared. Anyone knows what this one looks like?
A parabola.
It's a parabola, right? We know this one looks like the right side of a parabola. You know, we could get some points from this too, you know, and to show that it's a parabola. But for curves, it takes a lot more points, right? We could do -2, -1, 0, 1, 2. For lines, we only need 2 points. And if we plug in -2, we're going to get 4, 1, 0, 1, 4. So let's put in some number here. So if we plug in that, we get 4. When it's -1, it's 1. When it's 0, it's 0. When it's 1, it's 1. And when it's 2, it's 4. So our parabola looks like this, right? Now, can we see which one is on the top and which one is on the bottom? Which one is on the top? Where's the shaded region? This is our shaded region, right? We're looking for the region in between them.
y1.
y1 is on the top, right? The linear equation is on the top. I totally agree. 100% correct. Right? So y1 is on the top. So when we set up our integral over here, It's going to be y1 minus y2. What else do we need? We need the x values on the left and the x values on the right.
-1 and 3.
-1 and 3. And how are you getting that?
I'm looking at where
You're visually inspecting it, thinking that's the answer, right? You're just looking at it and say, it looks like that, right? Based on the numbers we have. But, you know,
Yeah.
this depends on how accurate our graphs are, right? So you have to be very careful. The best way to do this is to solve the equation. This goes back to your college algebra days again. To find out where they actually intersect, you're going to have to set y1 is equal to y2. Because where y1 is equal to y2, that's where they intersect. You see that? This is where y1 is equal to y2, and this is where y1 is equal to y2. So we have 2x plus 3 is equal to x squared. Now, how do we solve this? Well, we're going to bring over everything. It's a little more algebra than you would like, but it is what it is. Equal to 0. Now we're going to factor it. So it's x minus 3 and x 1 is equal to 0. Samir, it's not my phone, okay?
Oh, it's my laptop. Right. Oh,
it's your laptop. And
yeah.
if you turn this on, then we can't hear you. So, okay. So x is equal to 3 and x is equal to -1. So you were right, Louis. That means I did a very good job graphing it.
Oh yeah, that means you did it again. You did.
But you know, it can easily get messy and the numbers can be very fuzzy some of the time, right? So the real sure way of finding out where did they intersect is like doing y1 is equal to y2 and solving it. You with me?
Yeah. Yeah.
All right. If we go back to this equation above here, if we were to set f equal to g and solve it, then x would be equal to, you know, we're going to get an x1, an x2, and an x3 value because they intersect on 3 points.
Yeah.
Make sense? 3 points right here. So now we know which numbers to put on the left and on the right. -1 and 3. So you do have 3 problems like this when you're going to solve. And we continue setting up the area. So be -1 and 3. And y1 once again was 2x plus 3. This was our y1 minus y2, which was x squared. -1 and 3, and this becomes 2x plus 3 minus x squared. So after doing all of that, now we're ready to define the integration. You see, we have to do all that just to do the integral. We put it in descending order. This becomes -x to the third over 3 plus 2x squared over 2 plus 3x. And we have to evaluate that from -1 to 3. That's what the area is going to be equal to. And I'll leave that for you guys to finish. I think I might have an answer for that. The answer was 32 over 3. So when you plug in the 3 and you plug in the, you know, the -1, it comes 32 over 3. So you have 2 more such problem in the homework. So I didn't give you too many. Forward graphs, free without graphs, and the next 3 problems is this concept, which I want to talk about. It's actually much easier than the ones we did before. We don't even need the graphs, right? All it's saying the average value over a closed interval is equal to 1 over b minus a of the definite integral of f of x from a to b. Easy, right? Are you guys clear on that? Let's see. Let's try this problem. And this is question number 10 of 11. Find the average value over the given interval. So we're just going to use this formula, right? So the y average, the average value, is equal to 1 over b minus a. What is our b in this problem? You guys are overthinking it, right? Once again, it's the interval from a to b, right? It's 12, right? All these questions, you know, this is our a and b. This is our a value and our b value, right? It's the integral is from a to b, right? From a to b. These are the x. Look, we go back up here. You know, this is our a, this is our b. All these and if you go back to the rules, you'll see that. The rule says it's from a on the left to b on the right. So it's just the x values, it's the interval. All right, so the b is 12, right? Because it's b minus a, which is 0. Minus a, which is 0. And then we're going to take the integral from a to b. So our a, once again, is 0, and our b is 12. Of f of x, so now we're going to add in f of x, which is x squared plus x minus 6 dx. That's it. So what's the new thing that we're really doing? The only new thing we did was just add the 112 over it. Everything else is the same, right? Actually, we could probably skip this step. We could go straight to the integral, right? The integral of x squared is x to the third over 3 plus x squared over 2 minus 6x. And we're going to evaluate that from 0 to 2. And once we evaluate it, we multiply it by 1 over 12, and that's called the average value. So this is equal to 1 over 12. And this is going to be 2 cubed over 3 plus 2 squared over 2 minus 6 times 2. So that's plugging in the 2 right here. And then we're going to minus 0 cubed over 3 plus 0 squared over 2 minus 6 times 0. Now all of the 0 part just goes away. So this is 1 over 12. You don't have to do 0. No, but be careful, okay? Because sometimes there's a constant in there, and the constant would play a part. Does that make sense, Alfred? So maybe if we had like a hypothetically a +3 in here, right? You still would need to plug a 0 because this would actually become 3 then instead of just 0. But I agree with you. If there's no constant, the 0 is going to cancel out. Okay, we get a 0 and 2. I don't. I know I got a 0. I do not know how I got a 2. Don, what should the 2 have been? This was a typo on my part.
Oh, okay. So what's the actual number then?
What should the 2 have been?
I don't know. That's what I'm asking.
12, right?
Oh,
Yeah, I just left off the 1. My bad.
all right.
We're plugging in the 0. That's what's going to go down here, right? And the 12.
Oh, okay. All right.
Right? Because that's what we always evaluate with upper and the lower limit.
Thank you.
It's same A and B, right? That was, so this was our B, which was 12, and our A is 0. And this is our A, which is 0 and 12. So it's the same A and B. And it's the same thing I've been doing all the time, right? So once we get here, you have to plug in the 3 into everything. And then after that, you have to plug in the -1, right? And subtract them. Right, Don? I just wrote 2 instead of 12. Thanks for pointing that out.
All right.
Because maybe I confused someone else when they didn't say. And what was the answer for this? You know, this is going to give us some answer here. This was actually 8 over 3 plus 4 over 2 minus 12. And I think I got an answer from MindMatLab for this one, which they said was 48. Look, I wrote 2 again. 48. Is out for there. And this actually is incorrect again because we're plugging in the 12, you know, these are all 12s. So the final answer is 48. After you plug in 12, the zeros got canceled out. Let's just set one more up. And you see they're not much different. Done. 500 and that was the answer for the parentheses. 576.
Yeah, when you plug in 12.
So here this became 576. Is that what you're saying? And when you multiply that by 12, what do you get? 112. When you divide by 12, what do you get?
Oh, I forgot to do that. My bad.
So then that becomes, you know, 1 over 12 times a 576. Hopefully we get 48.
Yeah, it is 48.
Okay, there you go. So here's another one. Find the average value. So once again, the average value, y average, is equal to 1 over b minus a times the definite integral from a to b of f of x dx. Right? So our a is once again, keep jumping around here. Our a is the first number, the lower x value, and our b is the upper right value, right? So we know these numbers. So this is 1 over 9 minus 0 from 0 to 9, and the function is x squared minus 11 dx. And this was actually number, what number was this one? This is number 9. So it's equal to 1 over 9. And we're just going to take the integral of this, which is x to the third over 3 minus 11x. And we're going to plug in 9 and 0. So it's 1 over 9 times 9 to the third over 3 minus 11 times 9. And then we're going to do 0 to the third over 3 minus 11 times 0. And if you listen to what Alfred said because of the zeros, we don't even need to plug it in. There's no constant in that. So, whatever that comes out to be is our answer for the average value. So the average value is actually a little, it's easier than the last part that we did with the graphs, with no graphs. You guys have any questions for me before we go?